Welcome to this Algebra 2 session on Systems of Linear Equations, Part 2. So we're looking at determining whether an ordered triple is a solution to a system of three linear equations with three variables. And we're looking at solving systems of three equations with three variables. So a solution of a system in three variables is an ordered triple, x, y, z. And that ordered triple makes all three equations true. So there's three possible outcomes that you can see when you're working with these systems. One solution, no solution, and infinite solutions. So the first one that we're going to look at is solving 4x plus y minus 2z equal to 0, 2x minus 3y plus 3z equal to 9, and negative 6x minus 2y plus z equal to 0. So when you're asked to solve a system of three equations, the first thing that you want to check is are all three of my equations in the form ax plus by plus cz equal to d. So meaning x, y, and z all need to be on the same side. And in this system they are. Step 2 is to choose two equations and eliminate one of the variables. So I'm choosing the first equation and the second equation to work with first. Okay, so I'm choosing the first and the second equation to work with first. So what I'm doing is I'm going to eliminate a variable just like we've been doing. So I look at this one and I'm going to choose to eliminate y. So what I'm going to do then is multiply the top equation by 3 if I want to eliminate y. So the reason I'm choosing 3 is because this bottom variable, or this bottom equation, the y, has a coefficient of negative 3. So if I want to eliminate y, I need to multiply the top equation by 3 so that this y variable has 3. Opposite number. So multiplying by 3 gives me 12x plus 3y minus 6z equal to 0. On the bottom, this one remains the same, 2x minus 3y plus 3z equal to 9. Add my two equations together, and that gives me 14x minus 3z, because 3y minus 3y is 0, equal to 0 plus 9, which is 9. Now, guys, these are going to be long problems. Once you get the hang of them, they can be pretty quick. Lots of places to make mistakes, though, so you really need to be careful with your positives and negatives. So let's talk about our next step. Once we do that, we are going to eliminate the same variable that we chose in step 2 from any other pair of equations. And what that's going to do is create a system of two equations for us to solve. So going back here now, I have to pick another pair. I can pick 1 and 3, I can pick 2 and 3, but I want to eliminate the same variable that I did in step 2. So what I'm going to choose here is equation 2 and 3. So we're going to eliminate the y variable from equations 2 and 3. So to eliminate the y variable in these equations, I need to multiply. If you notice, we have a negative 3 here and a negative 2. So a common multiple would be to have a 6 there. We want one to be negative and one to be positive. So I'm going to multiply the top equation by 2 and the bottom equation by negative 3. That will give me a 6 and a negative 6. So multiplying there gives me 4x minus 6y plus 6z equal to 18. The second equation, multiplying the negative 3 through the parentheses, gives me 18x plus 6y minus 3z equal to 0. Adding together, 4x plus 18x gives me 22x. Negative 6y plus 6y gives me 0. And 6z minus 3z is a 3z, equal to 18. So now, if we go back to this other slide, we have an equation like we've been working with, or that we worked with yesterday, that has only two variables, and this one has only two variables. So now what we can do, step 4 here, is to solve the remaining system found in steps 2 and 3. And remember guys, if I'm going too fast for you, you can hit pause on any of the screens that we're on, or you can rewind and go backwards if you need to catch up on something. Alright, so next. Now we're going to take those two equations that we found and we're going to eliminate a variable in these. So you can see that this is already set up to eliminate the z variable because we have a -3 and a +3. So I'm going to work on eliminating z. So adding together, 14x plus 22x gives me 36x, equal to 9 plus 18 gives me 27. Divide both sides by 36, and I get x equal to 27 over 36, which reduces to 3/4. Now, the final and remaining step here is going to be to figure out what the other variables are. Oh, actually, let's go back one spot here. Now we found one of the variables, x equal to 3/4. Now what we're going to do is find another one. So what we're going to do is take 3/4 and substitute it back into one of our equations here that we use, and I'm going to use the first one. So I will have 14 times 3/4. Let's put what we're doing here. We're finding x. So 14 times 3/4 minus 3z equal to 9. 14 times 3/4 is 21 over 2 minus 3z equal to 9. And I'm going to get rid of the fraction. You can do it different ways. I'm going to get rid of the fraction by multiplying the entire equation by 2 over 1, which will give me 21 minus 6z equal to 18. Subtract 21 from both sides, and that gives us, I'm going to go up here, -6z equal to -3. Dividing both sides by -6 gives me -3 over -6, which is a +1/2. So now that'll enable us to find our third variable, because now we know the x value, we know the z value, and now we just take those two and substitute into one of our original 3 equations. So I'm going to choose to use this one, 4x plus y minus 2z equal to 0. I'm going to substitute the x value that I found in for x, so 4 times 3/4 plus y minus 2 times 1/2 equal to 0. 4 times 3/4 is 3 plus y. 2 times 1/2 is 1 minus 1 equal to 0. That gives me 2 plus y equal to 0, and that gives me y equal to -2. So my ordered triple here is 3/4, -2 for y, and 1/2 for z. Now what you can do is you can check to make sure that your answer is correct by taking all of these and substituting them into, oops, let me get back to the original page here, into each of the equations, and making sure that you get 0, 9, and 0 when you substitute them in. So that's the way to check your answer. 3/4, -2, and 1/2. Alright, last but not least, we're going to do one more. We're going to take another system of equations and we're going to solve it. I'm not going to write out all of the steps that I did before because we did that once already. We're doing 2y plus 2z equal to 6, -6x plus 5y plus 2z equal to 12, and -4x minus y minus z equal to 1. So I've already kind of arranged my problems here. Oops, that's 1, 2, and 3. So I'm going to work with equations 1 and 2 first here, and I'm going to eliminate a variable. So as you can see, it looks like it would be easiest to eliminate the z variable first, because we have 2's in front of the z's, and all we need to do is make one negative. So I'm going to multiply the bottom equation by -1. So that will give me -6x plus 5y plus 2z equal to 12. And that will give me negative 2y minus 2z equal to negative 6. Combining the two together, that'll leave me with negative 6x plus 3y, the z's cancel, equal to 6. And then for the bottom one, I'm going to take equation 1 and equation 3, and I'm going to eliminate the same variable of z. So here, all I need to do is multiply the bottom equation by 2 because I have a 2 here and a negative 1 here. So multiplying by 2 will give me opposite coefficients, opposite sign coefficients. So that gives me, the top remains the same. I'll put that in here in a minute. Multiplying the 2 through the bottom gives me negative 8x minus 2y minus 2z equal to 2. And then on the top, 2y plus 2z equal to 6. That remains the same. And I'm going to add. So that gives me negative 8x. The 2y's cancel. And the z's cancel here. So this works out really nicely, because I can get an answer for x right here in the beginning. So negative 8x equal to 8. Divide both sides by negative 8. And I get x equal to negative 1. So now I already solved for one variable. So what I'm going to do is I'm going to take x equal to negative 1 and substitute it into this first equation here. Negative 6x plus 3y equal to 6. I'm going to substitute the negative 1 in there and get that answer. So let's go to another slide here. So pause if you need to. So what we're doing is finding y, and we will have negative 6x plus 3y equal to 6 is the equation we're using. We know that x is equal to negative 1. We've already found that. So I'm substituting that in for x. So I have negative 6 times negative 1 plus 3y equal to 6. That'll give me a positive 6 plus 3y equal to 6. Subtract 6 from both sides, and that gives me 3y equal to 0. Divide both sides by 3, and I get y equal to 0. So last but not least, I'm going to find z here. We know that x equals negative 1. We know that y equals 0. So pick one of your equations from the original 3. I'm going to do the 2y plus 2z equal to 6. Y is 0. And so I will have 2z equal to 6. Dividing both sides by 2 gives me z equal to 3. So my answer set then is negative 1, 0, and 3. All right, that ends this session on Systems of Linear Equations Part 2.